Greetings to all. I am Dr.A.R.Mohamed Shanavas. Today we are going to discuss one of the important concepts of data structures, that is DQ, double-ended queue. In queue, we can insert the elements through one end called the rear, and we can delete the elements through another end called the front. The DQ is a special type of data structure on which we can perform both the insertion and deletion through both the ends. So through rear we can insert in ordinary queue, but through this end we can perform also deletion. And through the front we can delete elements, but in DQ we can also delete elements through the front. There are two types of DQ. One is output restricted DQ and another is input restricted DQ. In output restricted DQ, we can perform insertion on both the ends, that is rear and front, but deletion is possible only through front. In input restricted DQ, we can delete elements on both the ends, that is on rear as well as through front, but insertion is possible only through rear. We are going to discuss how to insert element in DQ, that is output restricted DQ, how to delete element in input restricted DQ. This is the algorithm for DQ insertion. Contain variables Q, front, rear, item and end. In insertion, we have to check the condition of overflow. Overflow is the condition that we have to check whether this queue is full or not. If it is full, we cannot insert any element. So the condition for overflow is if front is equal to 1 and rear is equal to maximum value, that is n. So that being the case, we cannot insert any more element. That is the condition of overflow. So in this case, we have to print a message, that is overflow, and return. Next condition we have to check is if front is greater than 1, then we have to decrement the value of front by 1. For example, let us consider my front position is here and I want to insert one data, that is 30. So for that, what we have to do? We have to create a space for that. So move the front pointer from 3 to, that is 2. So decrement the value of front and create the space, and on which I can store the data, my item. See, decrement the value of front by 1 and I am storing the item, that is 30, in the front of the queue. The second condition is if rear is less than n. Let us consider my rear pointer is here. I want to insert an element item, that is 50. So what I have to do? I have to move this rear pointer to the next position. It is in 5. Now I have to move it to the next position, that is 6. My rear pointer is now here. Now I can store the item 50 in the rear of the queue. The rear of the queue, item is 2. Return. Similarly, in case of deletion, we have to check the condition of underflow. So like in insertion, what actually we have checked is overflow, and in deletion we have to check the condition, that is underflow. If both the pointers, that is f, that is front as well as rear, is equal to 0, that means it is the condition of underflow, means the queue is empty. The queue is empty. If it is empty, we cannot delete. Already it is empty, so no item is available there. We cannot delete any item. The first condition we are checking in the deletion is if front is greater than 0, take the item, that is value, from the front of queue and store it in the variable that is item. See, let us consider this is my queue in which the front pointing that is position 2 and the rear pointing position 4. So what actually we are doing, we are taking the value from the queue of the front and store it in the item. So my queue, the front position is in 2, that is queue of 2, that is 20, the value 20 is stored in the item. So this value is what is stored in item. So what you have to do, you have to move the front pointer to the next position. So what you have to do, you have to move the front pointer to the next position, that is front is equal to front plus 1. So here we have one more condition. If the front pointer and rear pointer both are pointing the same position, let us consider both the pointer are here, and after deletion of this item, so what will happen? This F as well as R becomes 0. So what you have to do? You have to that is reset the value of the front as well as rear as 0. Okay. Otherwise, just to increment the value of the front, and store the item. See, for example, this is 30, 40, and it is here, and this data is outside. It is moved to the item. So automatically, what you have to do? You have to that is move the position of front to the next position. That is front is equal to front plus 1. The second condition is if rear is greater than 0. This is a condition. If the rear value is greater than 0. So here, this is rear position. See, for example, this is 50 and rear is here. And this value is stored in the item. Okay, so the queue of 5 represent what's that? 50. That item is stored in. That value is stored in the item variable. Now, what you have to do? This item is stored. So you have to that is move this R, that is a rear pointer, to the previous position, that is nothing but 4. So we have to subtract the rear by 1. Okay, we have to subtract 1 from rear. So now the rear pointer come to the position 4. Is that clear? So today we discussed about what is Dequeue, double-ended queue, different types of Dequeue that is available, output restricted Dequeue and input restricted Dequeue, how to that is perform insertion and how to perform deletion in Dequeue. Thank you. I hope you understood the concept. Have a nice day.